This is a high-performance FPV drone. They can go over 100 miles an hour, hit tiny gaps, and capture some incredibly dynamic footage. And today, I'm going to try and build one myself and then fly it into the biggest waterfall in Bali. I know this sounds crazy and it presents a few challenges. The first one being that I've never built a complete FPV drone before. I've repaired my drones and I've used parts from one to make another, but I've never handpicked all the individual components to build a complete FPV drone until now. And the second challenge, well, water and electronics, they don't mix too well. So I'm gonna have to find a way to make this thing waterproof, otherwise it'll end up dead in the water. Literally. But before we get to that part, let's start by building the custom drone. Here it is. This is the box of all the bits that I've custom picked to build my first ever FPV drone. Let's start with the frame. I decided to go with the AOS 3.5 V5. The frame is the main structure of the drone, made mostly out of carbon fiber with a couple of CNC metal parts too. Just look at how small the arms are compared to my 5-inch drone. We'll start off by attaching the arms to the bottom carbon plates. Now I picked this frame because it was a smaller drone, which means that I can transport it more easily, and also because it's compatible with all the other electronics that I'm planning to use. Got to give a shout out to my fellow Brit Chris Rosser, who's the guy who actually designed this particular drone. It goes together pretty easily, with the next step being putting the front camera cage together, and after that, the frame is pretty much finished. I also need to come up with a name for this drone. I've got a couple of ideas in mind, and I'm hoping that as we go throughout the video, it'll just come to me. Now, if you've got any suggestions, let me know down in the comments. The 3.5 in AOS 3.5 actually relates to the size of the propeller that this frame was designed for, so 3.5 inches. I've decided to go with the Gemfan Hurricane 3525 props, which should give a good balance of power, smooth flying, and stability. Next, we need motors so that we can actually spin the propellers and make this thing fly. Now, I love speed and power.
Speed and power!
So I went big. Maybe a little too big, but we'll find out later. Before we can fit the motors, we need to install these arm protectors. They just slide on and they'll be held in place by the motor screws. For the motors, I went with the Flyfish Flash 1804 2450 kV motors. Now, I know there are a lot of numbers right there, so let's break it down. 1804 is the size of the motor stator, so that's the bit inside of the motor, and this one is 18 millimeters in diameter and 4 millimeters in height, which gives us 1804. The second number is motor kV. Now this basically means how fast the motor is going to spin when you apply a voltage to it. The higher the number, the faster the motor is going to spin for the same voltage. So in this case, we have 2450, which means if we apply 1 volt to the motor, it will spin at 2450 revolutions a minute. Now, you have to balance this, because if you pick a number here that's too high, you can very easily burn out your electronics, but if you pick a number that's too low, you might not even be able to get off the ground. I think this should be the sweet spot for my chosen battery, so that's all 4 motors fitted. And speaking of batteries, normally on smaller drones like this, we run a 4-cell battery, which has less voltage than a 6-cell battery that we normally use on a typical 5-inch drone. To put things simply, the more cells you have, the more power that you have. Now, because these smaller drones are normally lighter, normally 4 cells is completely fine. But in the pursuit of
speed and power,
I decided to go with a 6-cell setup for this little guy. Now that's the same voltage that we typically run on a bigger drone, so if I get this right, this thing should absolutely rip. We need to somehow get that battery power to the motors, and we do that using a flight controller and ESC. The flight controller is the brains of the operation, and it does all the heavy computing, and it also makes sure that our drone is able to fly and do what we want it to do. And it works hand in hand with the ESC. ESC stands for Electronic Speed Controller, and its job is to feed power to the motors in just the right amount so that they can spin at the speed requested by the flight controller. This one is rated at 35 amps per motor, which for a small drone like this should be plenty. We generally refer to those two together as a stack because, well, you stack one on top of the other. I know, very imaginative. So how does the flight controller get information from my remote controller on the ground? Well, we need a receiver so that the drone can receive my control inputs. I'm going to be using the Radiomaster RP1 Receiver, which is running on the same ELRS 2.4 GHz protocol as my controller, all while being nice and compact for this small frame. Okay, so that's all well and good, but the drone needs to be able to film high quality cinematic footage all while sending that same video feed to my goggles on the ground so that I can actually fly the thing. That's where this comes in. I've decided to go with the DJI O4 AirUnit Pro video transmitter, or VTX for short. It is the latest and greatest in FPV cameras, capable of recording high quality 4K video footage, all while sending a HD video feed down to my DJI Goggles 3 on the ground so that I can fly the drone. It should be perfect for the shots that I have in mind, but it was at this point where I ran into my first problem. The screws that came with the kits to hold the camera to this 3D printed part were a bit too long and they weren't securing it down properly. But being an engineer, I got out the sandpaper and started to file them down so they were now the right length. This is how much I actually had to shorten the screws, and after a lot of sanding, all 4 screws were now the right length and everything fit perfectly. But then I ran into another problem. When I assembled the camera cage, I noticed that there was a big gap up at the top. Now, luckily I'd heard about this problem beforehand when I was doing my research, so ahead of time I already ordered in some slightly different 3D prints which had a thinner profile so that we can reduce the gap at the top and get everything to fit properly. It was here that I also noticed there were some other screws that were a bit too long, so I pulled those out, and you guessed it, I sanded those down to the right length too. I could then assemble the whole thing and we're good to go. Last but not least, I'm also installing a GPS module on this drone. It'll allow me to set up emergency return to home so that if the drone loses signal, it will automatically try and fly itself back to me. It also lets me see things like my distance from home and, more importantly, my flight speed. We all like to know how fast we're going, don't we? We'll do a speed test a little later on, so get your guesses down in the comments on how fast you think this guy is actually going to fly. The GPS that I'm using is the teeny tiny Flyfish M10 Mini, and here it is next to a GPS unit from one of my regular 5-inch drones. It should be perfect for this guy. There are a couple of other little bits to go into, like a capacitor, a buzzer, and some battery leads, but that's it. Those are all the components that we need to actually build this drone. Now, obviously, it's not gonna fly like this. We need to solder all the electrical joints together and mount everything in the correct spot. Now, I'm a bit of a perfectionist, so this might take some time. First up, soldering. Now, unfortunately, my soldering iron actually broke the other day, so I had to run out to one of the local electrical stores here in Bali and pick a new one up. And this is the best that they had in store. Now, this actually cost me less than £3 Great British pounds, but you know what they say, it's not the tool, it's the ability of the tool using the tool, something like that. Anyway, it'll have to do. Soldering gives us both an electrical and a mechanical joint in one. Now, luckily for me, I've actually been soldering for years, so this part isn't actually as daunting as it might be for others. First up, the motors. 3 wires for each motor. I've routed them neatly, cut them to length, tinned them, and then soldered them onto the corresponding pads on the ESC. It is vital here to be accurate and make sure that we have nice high quality connections to avoid getting things like short circuits or a bad connection, and of course I also want them to be nice and shiny, because a shiny solder joint is a good solder joint. The tape you see on the top there is just to protect the rest of the circuit board from any potential rogue solder balls that might go flying across it. After repeating the process 4 times, we now have 4 motors ready to rip. And speaking of shiny solder joints, just take a look at these. And if I can do this with a £3 soldering iron, then there's no excuse. Next, we'll make a battery lead. See, the one that came with the stack was a little bit too short, so I whipped one together and soldered it onto the ESC. The battery pads actually take a lot of heat to get them going, but with a bit of patience, we're all good. Then I'll add a capacitor, which helps us to protect the ESC from voltage spikes during operation. It is a vital component on a high-performance drone like this. Then it's onto the wire that connects the O4 Pro to the flight controller. The air unit does come with a cable with a connector on each end, but I won't be needing one end as these wires will be soldered directly onto the flight controller. I'm soldering all the wires here onto the correct pads on the flight controller, including the additional S-Bus wires in case I want to remove my other receiver later down the line and use the DJI controller. Now, this might cause some issues with my external Radiomaster receiver. Sometimes it does, sometimes it doesn't. We'll just have to wait and see. Speaking of receiver, that's up next. Making sure to wire this up correctly. Remember, TX to RX and RX to TX. Then we're going to solder the wires onto the GPS and then the GPS wires onto the flight controller. It was at this point that my cheapest chip soldering iron started to have a couple of issues. The tip was getting a little bit bent and it was struggling to get all the heat that I needed to do the soldering. But we pushed on and we managed to get it soldered on. Then I connected the buzzer and that's all the soldering done. Lovely job. Luckily the flight controller and the ESC are connected via a little wiring harness, so I just plug them two together and that's all the electronics done. Now it's just a case of securing everything down and getting the build complete. First up, heat shrink on the receiver. I'm also going to seal one end by giving it a bit of a pinch with some pliers. Then I put the antennas in for the VTX and then the VTX itself. I then secured the capacitor with two little cable ties, fitted the camera, and for the finishing touch added a battery pad and a battery strap. That's the build part complete. How does it look?
Life is cinematic, ominous classic. Living in the fast lane, can't nobody pass me. How I script the drama, I bet that you wanna know. Whoa.
Let me know down in the comments. I think it looks awesome, but now it's time for the moment of truth. So what I've got here, this is called a smoke stopper. It's basically like an electrical short circuit protection device. So we use this on the first time I'm plugging this in, so if there is a problem with the build, it's not just gonna burn the whole thing out and I have to start again. So this is nerve-wracking. So first thing, plug the battery into here. Whoa. Okay, now I'm gonna move the camera so you can see. And then I'm gonna plug this into the quad. This is extremely difficult with one hand. Okay, now it's in. And what I have to do is press this button. And when I press this button, we're then gonna find out if it's good or if it's bad. I'm nervous. Okay, let's do it. 3, 2, 1. We got all the beeps. It's alive. It's alive. GPS light is on. The receiver's got lights. Flight controller has lights. And we got the beep from the ESC. Okay, now it's time to do the programming, but I'm counting this little step as a win. We built an entire drone from scratch, all the pieces picked ourselves. We're doing good. I now need to program all of this so that the drone knows what I've installed on it and what to do and how to behave. So we do this using a piece of software called Betaflight. This is the operating system of the drone, and here I need to go through and meticulously set everything up. I need to make sure that things like my flight controller orientation is right, my motors are spinning the right way, my GPS is picking up satellites, my GPS rescue is set correctly, my rates are set up, the controller is able to talk to the receiver, and most importantly, my pit tune is correct. The pit tune is basically how the flight controller keeps the drone flying nice and smooth. Tuning it can be a bit of a dark art, but this is another reason why I chose this particular frame, because the frame's designer Chris Rosser is also one of the most knowledgeable people when it comes to tuning FPV drones. He's already gone through and created a custom pit tune for this drone, so for me it's as easy as selecting it and applying it to my build. So all of that setup looked good, but remember earlier how I said I was going to connect the S-Bus wires from the VTX just in case I want to change my controller later down the line and that I hope it would all be okay? Well, there was an issue. The drone was responding to my radio when it was plugged in via USB, but when I plugged it in using a battery, nothing. That's because the VTX comes to life with battery power and it was then sending signals down the S-Bus wire, which was giving me problems with my external receiver. The solution? Simple, just remove the two S-Bus wires that I probably shouldn't have even connected in the first place. But it was at this point where my soldering iron was pretty much on its last legs, but I did eventually manage to get them off, isolated them, and then, as if by magic, everything just worked perfectly. So that's the setup part all done, and it's time to do a quick control check. Now, I'm pretty confident that I knew what I was doing here, but if this is your first time, do not try this at home. Everything looked like it was working correctly here, so it's time to charge up a few batteries and head out for the first test flight. However, there is a bit of a problem. I'm getting wet. It will not stop raining. It's been raining for the past week here in Bali, and although this guy is destined to eventually get wet, we need to do our test flights before going ahead and actually waterproofing it. Oh, and for those eagle-eyed viewers, don't worry, I brought the laundry in too. Today is a big milestone day. It's going to be the first flight. The weather has improved a lot since yesterday. We've now got pretty much blue skies. It's very windy, but the ground has dried out, which is very important for one of my tests. So we've got a few tests to do today. Firstly, we need to make sure that this guy flies and that it flies well. We need to check out the tune, make sure there's nothing weird going on there. And then we're going to see how fast it can go. Everybody wants to know just how fast their new drone can go. So we're going to do a max speed test on this guy. And then one of the most important tests, we're going to have to do a GPS return to home test. Now we do have a GPS on this little guy. So we need to make sure that it's working properly and that it can fly all the way back and do a nice safe landing somewhere near the home point. So let's plug a battery in and get up in the sky. Okay, we're powered up and we already have 16 satellites, which is a great sign. We already have a GPS fix, so let's get up in the sky. Whoa. Okay, arming the quad now. Oh, okay, this is nerve-wracking. We're gonna push up the throttle. Hopefully it leaps into the sky, controlled and ready to go. It's a bit windy. Let's do it. And we're up. Okay. Okay, first step, we are flying. And it looks incredibly smooth. Very nice. Bring it past me, see how it sounds. Sounds nice, sounds smooth. Not getting very good performance from my radio link, but I can look into that a bit later. Wow, it's very smooth. Chris Ross's tune coming in beautifully here. Wow, this flies so smooth. That's my first impression off the bat. Incredibly smooth. Let's give it a bit of a punch. Woo-hoo. Very nice. Okay, let's get on to the max speed run while we still have a nice, fresh, full battery. So I'm gonna go over here and then we're gonna punch it. Final guesses in the comments. I think we're probably going to get around 150 kilometers an hour. And go. 160. Whoa. That sounded epic too. Did a bit of a flip. Very nice. Wow, this flies so nicely. Okay, so tune. I'm happy with the tune. It flies beautifully. Radio link seems a bit iffy. I might have to just update to the latest ELRS because there has been a known issue with the Goggles 3, although I'm pretty sure I did put on one of the latest versions, but we'll just double check that. So we're going to do the GPS return to home tests. I'm going to put it somewhere safe and I'm going to activate GPS rescue. Now the distance to home looks correct, the home arrow is looking correct, so hopefully it makes its way back correct. So I'm going to activate it now. GPS rescue is active. It is now ascending. It's going to ascend to the maximum height that I flew at during this flight. So we can see on the right there, it's ascending up. We've gone to 73 meters. Now it should make its way back towards the home location, which it is doing so. This is looking good. It's going to slow down when it's above the home point and it's going to descend until it lands. Now okay, I'm going to go have a look. Okay, it's looking good. Let me take you along with me so we can accurately see where this guy is going to finally touch down. Can you see it? It's coming down. It's not super close to the home point, but it's definitely close enough. Is it going to get a bit closer? Maybe the wind is not helping it a bit here. And come on, touchdown. There's the home point for reference. I'm estimating that is roughly 3.5, 4 meters, something like that. So not pinpoint, but definitely close enough to get it back to you and then you can take over. Okay, I'm going to do a bit more flying with this guy and then we're going to have to move on to the all-important step, which is going to be waterproofing. This drone was flying awesome, and when I landed at 3.5 volts per cell, we'd actually been flying for just over 8 minutes, which is very impressive. I still need to come up with a name for it, but nothing has come to me yet. I also brought out my other 3.5-inch drones so I could do a bit of back-to-back testing, and it's amazing how two very similar drones can also feel very different. They both fly very well, but they feel so different. The EOS feels like a really smooth high-performance car, like a Bugatti, whereas the Volador, that feels more like a Lamborghini. It's more on the edge, and it makes you want to fly faster, and to be honest, it makes you want to fly like a bit of a crazy person. Flying this also let me check to see if it was performing similar when it came to radio link, and it was pretty similar, so I think there was just some interference coming in from this nearby radio tower. Test flight complete, but we can't go to the waterfall yet, because I can categorically say that if this thing touches water right now, it'll turn into a $500 doorstop. This guy isn't waterproof at all, so we need to head back to the workshop, try and waterproof everything, and then, hopefully, we can go and get that amazing shot. Honestly, this is the part that I'm the most worried about, because if I don't get this right, this entire drone could be destroyed. To waterproof it, we need to take the whole drone apart again so that we can get access to all the electronics. To actually make them waterproof, I'll be using a combination of this MG Chemicals silicon conformal coating and this high temperature black silicon sealant. I start by filling the other end of the receiver heat shrink. Now I already crimped one end which should be watertight, so I'm just filling the other end in with sealant to make that end watertight too. So I then use the same black sealant on the capacitor, top and bottom, just for good measure, and next up are the flight controller and ESC. I coated these using the conformal coating, so I just paint it on with a small brush, making sure to avoid getting any on the barometer. The barometer is this little guy right here. Now the hole on this component needs to be exposed to the atmosphere so that it can sense the air pressure and give me a correct altitude reading. If I get any coating on or in this hole, it's game over. But luckily I have a steady hand and I managed to avoid all of this whilst coating the top and the bottom of both boards. I gave them both 2 coats just to ensure good coverage. I then put them outside to dry because the fumes that come off this stuff is really quite intense. Then I moved on to the scariest part of this entire process, waterproofing the O4 Pro air unit. See, I've waterproofed flight controllers and ESCs before, but I've never attempted to do an air unit. The thing that most people report after they've coated an air unit is that it starts to overheat really quickly and it can even shut down mid-flight due to getting too hot. So I've got to be really careful here. I start by opening up the unit, disconnecting everything and then removing it from the casing. You can see here that it has some thermal paste on it to help with that heat dissipation, so I scraped it off and kept it for later. Ideally I would apply fresh thermal paste, but I've no idea what kind of thermal paste this is, so I'm sure it's going to be fine. After cleaning up all the residue, I put some blue tack over these tiny connectors to prevent any of the coating from getting in there, and you can actually see that the board already has some conformal coating on it, but not everywhere. So there's a bit of protection, but not enough for my liking. I did the same process of painting on the conformal coating, making sure to get everything covered, but not to go too thick on here, just to help with the heat dissipation. I also left the tops of the main chips uncoated, so they'll be able to get a better thermal transfer through the paste when I reapply it later. This should be completely fine, there's enough coating around the edges to make sure this is still waterproof. I then moved on to the camera, which was a little less daunting because it's already kind of a sealed box. So all I did here was took it apart, and then I put some silicone sealant around all the different areas which had gaps, basically just to make a one sealed unit. First off around the camera lens and then also around the main joint. I also put a little bit on the back here just around the cable, just for good measure. Going back to the main board on the VTX, there's this metal cover here and it's got a little hole in it. Now, I'm not really sure the purpose of this hole, so I still want to make it waterproof, but I need to make it removable if this actually needs to be there. So I just used some of the black silicone to cover it instead. I can remove it if I need to later. Once this was all done, I then put everything aside and left it overnight to cure. The next day, after everything was set, I started to put the whole thing back together. So I reapplied the thermal paste, mounted the board back in, fastened everything down, and that's the air unit pretty much good to go. Back in goes the ESC, flight controller, and everything else. So it's time now for the second moment of truth. Does it all still work? Let's listen for the beeps. Result, everything was working fine. I had video in my goggles, but would it overheat? I put it outside in direct sunlight, plugged into a battery and left it for around 5 minutes, and it was completely fine. No excess heat, no shutdown. It was looking really promising. So I took it for a quick shakedown flight, and now it's time to get it wet. Okay, this is by far the scariest part of the project. I'm actually I'm really nervous about this. I've been pretty happy with the rest of it so far, but putting it in there, don't know, just fills me with a little bit of doubt. But we've got to test it. Okay, the quad is ready. I put an old battery on it just in case. I'm going to do this in angle mode, so hopefully it's a bit easier to control whilst it's on there. Now it looks like it might start raining in a minute, but this is a water test, so this is terrifying. Motor's armed and we're up. Now the aim here is just to let the drone kiss the surface of the water a few times so it can get nice and wet, but without going fully underwater. First dip, fine, but if we take a look in the goggles, we can see that we got a crazy spike here on our current sensor, which is now reading way higher than normal. This isn't a good sign, but because I was flying the drone from line of sight and I wasn't wearing the goggles, I actually didn't see this happen. So I just carried on flying. Oh my god, it's getting wet. Second dip, fine. Third dip, and it's in the water. That's not good. It looks like we had an issue here with the flight controller or the ESC because we can see the drone spin out of control just before it drops into the water. I had no option here but to just dive in and save it from the bottom of the pool, remembering to unplug the battery before I took it out of the water. Not gonna lie, right now, pretty disappointed with what just happened. It looks like there was something went wrong with the ESC there, the way it flipped over and went down. Don't know whether I didn't do a good enough job waterproofing that, although I do now remember that I didn't actually put any silicone around the cable that connects the flight controller to the ESC. On the actual cable, I don't know if water somehow shorted that on where the pins go in. I don't know. I'll take it apart, do some troubleshooting, see if it survived or not. I got to work stripping it down and drying it off, and this is the cable that I was talking about. I'd forgotten to waterproof the part where the cables actually go into the connector. After I dried it out, I plugged it into the computer, and it looked like it was all still working. So I plugged it in with a battery using the smoke stopper. Okay, all good, all the beeps were there, so I tried spinning the motors just to make sure the ESC wasn't damaged, and they all span as expected. So I sealed the cable and let it fully dry out. I think I might have got really lucky here. I've plugged everything in, tried it, and it all seems to be working. The motors are all spinning, which means the ESC is fine. I'm getting video in the goggles, the SD card appears to have died in the process, it must have shorted out. But apart from that, everything does appear to still be working, so we might have another shot at this. I'm gonna put some silicone over the ends of that cable, which I think might have caused a problem. It was soaking wet when I got it out. I think that might have just caused the flight controller on the ESC to just shut down when it sensed a short or something. I'm not sure, but it tripped out, it went down. I never planned on this drone to be fully submerged underwater, but it's taken a full submersion. It survived, fingers crossed. I'm gonna silicone those bits, let it dry out. I'm gonna put it under some moving air. I'm gonna try again very soon. Man, I was ready to give up on this, but come on. We can do this. Okay, we're back. It is starting to rain again, but I'm going to first off just do a quick hover test, make sure it's flying okay, checking it's all still working, and then we're going to go again in the pool. The silicone isn't fully cured, but it's cured enough to, prevent water getting in. Feeling a bit better about it this time, but we saw what happened last time. Let's hope I don't have to go for a swim again. We're up. Take two. Let's try again. First dip. Okay. Oh, we got wet that time. This pool test is pretty extreme and it's getting more wet here than it will do at the waterfall, but it's better to always test things in a tougher environment than you're expecting them to operate in, just to be safe. Looking pretty good this time. Second dip, looking good. Okay. It's looking good. 3 times the charm on the dunk. Third dip, okay-ish. Do you see that twitch? That's not supposed to happen. I then tried to do a quick hover test to see if it was okay. No, don't tell me it's died again. Okay, I'll tell you instead. It's not working anymore. Hear these beeps that keep happening? Well, that's the stack resetting itself over and over again. it wouldn't arm, and when it would, one of the motors wouldn't spin, and it would just kind of freak out. My OSD was also flashing on and off, which isn't a good sign either. This was a pretty bittersweet ending to what was looking like a pretty promising test. Okay, so I initially thought it was okay, but just before I landed it did a little bit of a twitch, which was a bit bizarre. So I've brought it back, had a look at it, and it appears that we've damaged the ESC somehow. So I'm not sure what to do about this. Maybe we'll try and let it fully dry out and see what happens, but I've really just about had it with this thing, to be honest. Probably gonna have to order a new stack and replace that and try again. The air unit seems to have survived okay, but yeah, this is not good. It's definitely not good, and I'll be the first to say that I thought this was all just going to work completely fine first time around, and it's actually really disappointing to see something that you've worked so hard to try and make work fail. But I've come too far to give up now, and if you know me, you know that I'll always find a solution to the problem no matter how hard it is or how long it takes. I let the whole thing dry out again and got back to it. Stripped it down again, recoated the boards with more conformal coating just to be safe. I then added more silicone around the connectors on the air unit and the cable from earlier, and after letting all of that cure, I plugged it in and we're back in action. Third time's a charm, right? Okay, so I'm gonna try again. Last time. This time I'm gonna do 2 dunks in the pool, make sure it's nice and wet. Then I'm going to fly the remainder of the battery to make sure it keeps flying and is going to be okay to fly once it's been wet. And then what I'm going to do, I'm going to take it out, I'm going to fly like another 6 packs in the dry just to make sure that everything is still okay. Fingers crossed it works this time because it's taken quite a lot of effort to get to this stage. Luckily I haven't had to replace any parts. The only thing that did die was that SD card. But yeah, the sun has come out today a little bit, so maybe that's a good sign. Here goes nothing. Okay, nervous, but let's do it. At this point, I was pretty hesitant to get it wet for obvious reasons, but I knew what I had to do. I'm scared to dunk it in. First dunk, good. Second dunk, good. Okay, that's it. Big dunk. What I'm going to do, I'm going to bring it back and land. I'm just going to check to make sure that my current sensor hasn't gone crazy. Current sensor is still looking normal. Okay. I think we might be okay with this one. Have a quick look. Everything is soaking wet. All I have to do now is fly the rest of this battery pack with nothing going wrong, and we can finally move past this terrifying cool testing. This time around, everything was looking good. That was until I landed for my second mid-flight check-in to find this. That's me looking into the goggles and seeing absolutely nothing. The video feed had completely disappeared along with all of my on-screen display telemetry. At this point, I knew that something was wrong and I was scrambling to find out what the problem was, but I couldn't figure it out. There was a light on the air unit, but nothing was coming through to the goggles. It wasn't even connected anymore. Maybe this time it was dead for good. I came back inside and stripped the air unit to try and figure out what was wrong, but to be honest, I couldn't see any issues. Maybe it just couldn't handle what I'd put it through. Okay, well that's not how I expected this to go. Unfortunately, at some point during that last test over the water, the air unit just died. It was working fine when I checked to see that my OSD was working with all of the, to check my amperage rating. But then it just turned off and I cannot get it to come back on. I've checked everywhere. There's no water in places where there hasn't already been water. Everything actually looked pretty dry when I took it apart. So I'm not sure. Honestly, I'm pretty gutted. This is not how I expected this video to end. I really wanted to get that shot at the waterfall, but I don't know if I can warrant going out and buying another one of these just for this video. So yeah, pretty disappointed to be honest. And unfortunately, it looks like I'm just going to be taking an L on this one. So yeah, it's not how I wanted this video to go, but it is what it is. Hang on a second. Didn't I say just a minute ago how I would always find the solution to the problem no matter how hard it was or how long it takes? Is this really me giving up? Well, I took a minute, sat down to let myself gather my thoughts, and then it hit me. But actually, There is one thing I haven't checked. So in the camera, there is a connector here, which is one I've already taken off and checked, but there's a second one. So I'm going to take that off. I'm going to see if any water had got in there from before and then got a little bit of crust, because obviously the pool does have a bit of salt in there. Let's check that. Yeah, let's check it. So I removed the glue holding the connector in place and then popped the connector off. There was a tiny bit of crust in there, you actually can't see it on the camera, but I cleaned it off using a toothbrush. Inside the camera housing did actually get wet when the drone got fully submerged. I already cleaned it out and resealed it at the time, but I guess there was still some pool salt floating around in there, and once it dried out it must have just clung onto something and it was starting to give me some problems. So after cleaning it off, I put it back together, plugged it in, and well, that beep sounds like video. There's no way. There's no way. It's working. There is no way. I'm honestly shocked. Okay, maybe we're not taking an L. I'm gonna have to waterproof this thing again for like the 5th time. I'm gonna have to run these tests again. Okay, we might still be on. I don't know what to say. At this point, the highs and lows of this project were really starting to take their toll on me. Yesterday, I thought it was all going well, and then I ended up going for a swim, then I repaired it and it was looking good again, only to twitch after the last dunk and need yet more work, and then just 20 minutes ago, it was starting to look good again, only for the video feed to vanish and me think the whole air unit was completely dead and the project was over. It's been a lot so far, so I got the silicone out again, and this time, I didn't care about things looking pretty. I needed to make sure 100% that this thing would be waterproof. I also added some holes in the arm guards to help water drain away from the motors, as I think there was getting some water trapped in here which was giving me some issues. After letting everything cure again, I went back outside and got ready to run the tests. At this point, I was no longer scared about it getting wet. I needed to know if it was going to work or not. I started by getting it wet with some low flying, and then first dip, good. Dripping, come on. Second dip, good. Third dip, good. Fourth dip, good. Fifth dip, let's make this one big. Whoa, that's wet. Okay. Let's bring it back, check we've still got video, and then we're gonna fly it. We're back. Video. Still there. Check the amp meter. The amp meter's gone wild, but we are still flying. The current sensor was showing very high again, so I gave it a good shake to remove any potentially trapped water. Shook it out. The amp meter appears to have gone back to normal. Let's finish the battery. This is the first time that we've made it past all the dumps, and we're actually still flying with everything working. All we have to do now is finish the battery pack without anything going wrong. Time for the second mid-flight check-in. Check this again. Video is still there. Amp meter has reset and is behaving itself. This is looking promising. Okay. We're up again, and I flew and flew and flew. I even came right up to the camera just to say hello, and then when the battery was depleted, it was time to land, but was everything still working? Yes, we still have video. The amp meter is perfect, it's where it should be. It says my SD card is full, or it's not there. Did I put one in? Maybe I did, maybe I didn't. We can finally move on to step number 2, which is post-wet testing. Wow, this is crazy. Okay, unbelievable. We can finally move past the pool testing and onto stage 2. We've just got to hope that that SD card slot dries out and starts working again. So I packed my bag and went to the field for part 2 of this testing. 6 battery packs back to back. At this point, my confidence in the drone had improved a little, but I still wasn't fully confident in it. So to make the test even harder and to give me some more confidence in it, in between each flight I actually sprayed the drone with water so that I would be 100% sure when the time comes that it would be ready. This part of the testing was actually going really well, and after around 3 packs, the SD card slot had dried out and started working again. And for the first time since what felt like the first test flight, everything on the drone was working perfectly. I gave the drone a real good rip around to really put it through its paces and give it a thorough shakedown. And it's safe to say that by the end of this test, the drone had proved itself worthy. I was so happy with this, and it felt like I'd overcome a massive hurdle on my journey towards the waterfall. And speaking of which, it is getting very close to crunch time, but we still need a name. See, this drone is designed for water and for land, well, and also for the air, but he's kind of amphibious. Well, he's actually survived a full swim at over 1.5 meters, but yeah. I also kind of thought when it was skipping along the surface of the water that it kind of reminded me a little bit of a frog. And he's also a little bit wide in the middle, also like a frog. So, ladies and gentlemen, I present to you Froggy. Okay, Froggy, let's go chasing waterfalls. So, it's crunch time, and the journey to the waterfall gave me a lot of time to reflect on everything that we've achieved so far. I built a custom FPV drone which flies awesome, even though the waterproofing process was full of ups and downs and making me want to quit and give up on the project entirely. I resisted the urge to quit, kept going, and managed to get the drone working reliably. And now, I'm heading to the biggest waterfall on the island to try and capture a shot that I've had in mind for a very long time. It's been a roller coaster of a journey leading up to this, but hopefully everything holds up. Here we are. This is Bali's biggest waterfall at 100 meters height. This powerful giant does not take any prisoners. If I don't get this right, it is not going to be pretty. I'm going to let a few more people fizzle out and then we're going to send it. I'm nervous. Okay, let's do it. Come on, Froggy. Oh, I'm shaking. Okay, we're up. Wow, we're getting peppered already with water. It's not going to be the clearest image, but I might have to come back and clean this lens. Whoa. Really want to see if I can fly behind it. Okay, I'm going to have to clean my lens. It got too dirty off the rip. Let's quickly clean the lens. Gonna have to just get straight up and going. Okay. This is where things start to get real. Oh, wow. Quick test. Oh, so good. We've got to actually brave it and we've got to go in the water. Come on, Justin. This is why you built this thing. Let's do it. Come on. Okay, feeling it. This is the one. Wow, the picture's so bad with the light there. We're going. Didn't quite get in as much as I would have liked to there. Here's the waterfall. Sling it in. No. There's a wind. There must be a headwind coming over there. This is such a hard waterfall to get into, man. I was really struggling to fling the drone into the water. There was a headwind, and every time I got up past the top of the waterfall, it would blow me back and away from that perfect line. I got close to the water a few times, but I didn't come all this way through endless waterproof testing and repairs just to get close to the water. Froggy needs to go in the water. Close just won't cut it. Okay, this is the one. Let's do it. Beautiful dive, revealing the waterfall. Couldn't it close? Come up. Here we go. Come on. Come on, Froggy. Come on. Come on. Into the water. Into the water. Into the water. This is it.
What you waiting for? People ready to ride.
we go. That's the ticket. Oh my god. Whoa. Oh my god. That was crazy. I would like to fly behind the waterfall. After getting that quite frankly mind-blowing shot, I also wanted to fly behind the waterfall just to explore a little more and put Froggy through his paces. Whoa! That is beautiful. In the water, yes, come on. As luck would have it, the last time that I came here to fly the Avata 2, I actually had the same guide as I had today. He's an awesome guy, and I showed him how I'd leveled up my shot a year later on. As I celebrate this monumental achievement, take this as a reminder to push yourself to try new things, take on new challenges, and see what you're really capable of. There might be some hiccups along the way, but in the end, it's always worth it. Come on. It was worth all the pain, it really was. Wow.